problem. I want to look at the length of my sides. I want to know if it's a triangle. If it is a triangle, I want you to classify it as acute, right, or obtuse. Well, we're going to use our distance formula here. I want to find the distance from A to B. So we're going to say 5 minus 2 squared plus 7 minus 2 squared. Notice when we get that, we will get 3 squared plus 5 squared, which is 9 plus 25. I'll get the square root of 34. And on this one, I think I'll approximate that. So the square root of 34 is about 5.83. Next, let's do BC. Now I'm not going to show my subtraction here, but 10 minus 5 is 5 squared, plus 6 minus 7 is negative 1 squared. So I'll get 25 plus 1, which is the square root of 26. And if I take the square root of 26 in my calculator, I get about 5.1. Finally, let's do AC. Once again, I won't show my subtraction here, but I'll do it. 10 minus 2 is 8 squared, plus 6 minus 2 is 4 squared. So I'll get the square root of 64 plus 4, which is the square root of 68, which is about 8.94. Well, notice if I add up my two shorter ones, 5.83 plus 5.81, it's bigger than 8.94. So I have a triangle. Now, to find my triangle, I'm going to compare C squared, my biggest side, with A squared plus B squared. So I'm going to say the square root of 68 squared. I'm going to compare that with the square root of 34 squared. Let me rewrite that. Plus the square root of 26 squared. Well, the square root of 68 squared is 68. So how does 68 compare to 34 plus 26? Well, notice 34 plus 26 do that. 34 plus 26, to be able to do that in my head, is 60. Well, 68 is greater than 60, isn't it? Since it's C squared is bigger, I've got an obtuse triangle. So we just do Pythagorean theorem kind of in reverse. And then I want to compare it. Now we do have two special cases of triangles. The first one is an isosceles right triangle. So I'm going to come up with an expression for C here. C squared equals A squared, which is X, squared plus X squared. So C squared equals 2X squared. Take the square root of both sides. C is X times the square root of 2. So if I have a right triangle, a right isosceles triangle, I multiply the square root of 2 times one of the legs to give me the hypotenuse. And I would divide it. If I know the hypotenuse, I want to find the legs. This is one of those you need to do quickly. I do not want you doing Pythagorean theorem like we did here each time. You're going to waste your time. These are questions that show up in the ACT because they want you to know it. You have 60 minutes to do 50 questions. Some of you can't do 15 questions in a geometry test in 60 minutes. And they're not as complicated as you're going to see. So we need to work on our speed. Now, if we take a look at this first one, notice on this one, my leg is 4. Since it's isosceles, I know the other side is 4. So to find the hypotenuse, I just say 4 times the square root of 2. Maybe I should write this out so without x's and y's because they show up all the time. I've got my leg of my hypotenuse of my right triangle, and I know the other leg is going to be the same length. And then what I do to find the hypotenuse, I take whatever the leg is, I multiply it by the square root of 2. There's a formula for you per se. So on the next one, notice my leg is 5 square roots of 2. So to find the hypotenuse, I take my leg, which is 5 square roots of 2, and I'll multiply that by the square root of 2. Well, square root of 2 times square root of 2, that's 2, isn't it? So my hypotenuse is 10. We multiply by the square root of 2. That was kind of a long seminar. Let's do the next one in a different section.